Let's take a look at this problem. We got 2 over 26x. The instructions say give the restrictions on x to the following rational expressions. If there are values of x for which expression is undefined, then write no restrictions. If there are no values for which of x for which expression is undefined, then write no restrictions. Okay. When they say give the restrictions, they're saying basically find the domain. So remember our 2 steps. We set our denominator equal to 0 and solve it. Well, this one's just a simple linear equation, so we'll divide both sides by 26. And we get x is equal to 0. Now, our restriction is, remember this is the value x cannot be, so we put a slash through the equals, x cannot equal to 0. That's a restriction. If we were to put 0 in for x, we'd have 26 times 0, which is 0, and can't have a 0 in the denominator. Okay. Number 2, y over 3x plus x plus 6 over 8x. And it says perform the indicated operation of addition on 2 rational expressions to reduce your answer to the lowest terms. Okay. First off, let's look at the numbers. 3 and 8. Our LCM of 3 and 8 would be 24. So we'll have 24 here, and we'll have 24 here. Now for the x's, we're looking for the greatest number of x's in a single denominator. There's 1 here, there's 1 here, so greatest number of x's in a single denominator is 1. Okay, now you ask yourself, what did you multiply by the bottom to get your new denominator? I multiplied the x's already there. I multiplied the bottom part by 8, so I have to multiply the top part by 8. And over here I multiplied the bottom part by 3, so I have to multiply the top part by 3. So we get 8y over 24x plus 3 times x is 3x, 3 times 6 is 18 over 24x. And now they have the same denominator, so I'll merge together the top parts. So I got 8y plus 3x plus 18 all over 24x. Okay, problem number 3. On a map, each inch represents 4.5 miles. What is the distance represented by 3 inches? So set up the proportion for the word problem. So on a map, each inch represents 4.5 miles. So we're saying 1 inch over 4.5 miles. That's our ratio. Then the other one is what is the distance represented by 3 inches? So they're telling us 3 inches. Now inches is up on top here, so inches has to be up on top here, and they're wondering what distance is, so this is x. Now that's our setup, and I'm going to drop the units of measure now. So I got 1 over 4.5 equals 3 over x. Now cross multiply. Remember, if you got a proportion, a single fraction equals a single fraction, you can cross multiply. So I'll multiply those 2 together, and I'll multiply these 2 together. 1 times x is x. 4.5 times 3 gives us 13.5, I believe. Excuse me. So 13.5 miles. Okay. Number 4. I got x over 2 equals x over 3 minus 1/2. And setting restrictions on the variable, then solve it. Okay. Well, I don't have any variables in the denominator, so there are no restrictions on the variable. So let's just go through and solve this. This is, you could say it's a rational equation. Rational equation basically means you have an equation and you have a fraction in there. Specifically, our steps for solving a rational equation was when we had a variable in the denominator. This one I'm going to solve with my linear equation steps. So my first step, get rid of parentheses, don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. We got 2, 3, and 2, so our LCM would be 6. So I take 6 times x over 2 is equal to 6 over x over 3 minus 6 times 1/2. 6 and 2 both divisible by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. 3 and 6 both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 6 and 2 again both divisible by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So we got 3 times x, 3x, equals 2 times x, 2x, minus 3 times 1, 3. Third step. Get everything with an x on one side, numbers on the other. So I'll take this 2x and move it over. So we get 3x minus 2x equals negative 3. Combine like terms, 3x minus 2x is x, so we end up with x is equal to negative 3. Okay, 5. Perform the indicated operation of multiplication, division, and simplify. So we got y squared minus 15y plus 54 over y minus 8 times 3y squared minus 22y minus 16 over y minus 9. Okay, now our steps. First step is to factor everything. And this on top here is a PSD method. Y minus 8 can't do anything with. This is the key number. And y minus 9 we can't do anything with. The reason why this one's PSD is because we have y squared, y, no number in front of your y squared. The reason why this is key number is we have y squared, y, no y, and there's a number in front of your y squared. Okay, PSD. Take the number at the end, ignoring the signs. So we got 54. And we'll come up with our 3 columns. Write down all products give us 54. We got 1 times 54, 2 times 27, 3 times 18, 4, no, 5, no, 6, 7, 9. Okay, add them. 1 plus 54 is 55, 2 plus 27 is 29, 21, 15. Subtract them, smaller from larger. 54 minus 1 is 53, 27 minus 2 is 25, 15, and 3. Okay, this one's a little tricky. We got 15 in both columns. If you're not comfortable with the signs, you try one, see if it works. When I say see if it works, you multiply back through and see if it gives you the original problem. In this case, since our last sign is a positive, that means our number we're looking for is in the S column. So I know this is a 15 I'm looking for. So I'm going to use 6 and 9. Okay. Our larger number that we're using, which is the 9, will always be same sign as the middle term, which in this problem is negative. The number I circled is in the S column, S for same sign, so if this one's negative, this one has to be negative. And let's take a look at this one. We got 3y squared minus 22y minus 16. Key number, we take the number at the beginning times the number at the end, ignoring signs. So we got 3 times 16, which gives us 48. We got 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. Add them. 1 plus 48 is 49, 2 plus 24 is 26, 19, 16, 14. Subtract them, smaller from larger. 48 minus 1 is 47, 24 minus 2 is 22, 13, 8, and 2. Number we're looking for is number in our middle term, which is 22, which is right here, which means we use 2 and 24. The larger number that we're using, which is the 24, will always be the same sign as the middle term. And remember, with the key number, we're going to rewrite our middle term using those 2 numbers. So 24 is negative. Number I circled in the difference column. D for different signs means one's positive, one's negative. If the 24 is negative, the 2 has to be positive. And then we factor by grouping. First group has a 3y in common, and that gives us y minus 8. Second group has a 2 in common, and that gives us y minus 8. Now our goal was to get this parentheses the same as this, which they are, so I'll factor out a y minus 8, and that leaves us 3y plus 2. Okay, so this becomes y minus 8 and 3y plus 2. Step 2, cancel. Only guideline is one's on top, one's on the bottom of the same. So we got y minus 9 here, we got y minus 9 here. We got y minus 8 here, and we got y minus 8 here. And we're left with y minus 6 times 3y plus 2 over 1, but that 1 can disappear. Typically, though our fraction disappeared completely, typically we don't actually multiply it back through. It's hard to say what the answer would do in this problem. I would take this, or I'd take if you multiplied it back through. Okay, problem number 6. We got 5x minus 4 over 5x plus 8x plus 1 over 5x. Now they already have the same denominator, so all I have to do is add or subtract top parts. In this case, add. So we got 5x minus 4 plus 8x plus 1 over 5x. Combine together like terms. 5x plus 8x is 13x. Negative 4 plus 1 is negative 3. So we got 13x minus 3 over 5x. And that's our answer. Number 7. We got negative 7x squared over 3x minus 3. And the instructions say give the restrictions on x for the following rational expression. If there are no values of x for which expression is undefined, then write no restrictions. Okay, basically they're saying find the domain. First step. Set your denominator equal to 0 and solve it. So we got 3x minus 3 equal to 0. Now to solve this, I'll take the negative 3 over. It becomes a positive 3. Divide both sides by 3. And we get x is equal to 1. This is our value that if I put 1 back in up here, we get 3 times 1 is 3, minus 3 gives us 0. This is what causes the denominator to equal 0. So our restriction is we put a slash through the equals, and we say x cannot equal to 1. Okay, number 8. This looks like a variation problem. Now what tells me that is I see it says varies. Varies inversely. Okay, so let's go through our steps for solving a variation problem. Our first step says to determine type. Well, it specifically says varies inversely, so it tells us inverse. Now typically our form for inverse is y is equal to k over x. Step 2, pick variables that make sense. And it says if y varies inversely as x squared. So varies inversely is where your equals goes. So we got y equals varies inversely. The inverse part always goes down your denominator. And it says as x squared. So this wasn't very different than this. We used x's and y's again. But it tells us this is x squared. Step 3. Look for your one example. Varies inversely as x squared, and y is equal to 3 when x is equal to 12. There's my example. So we got y is equal to 3 when x is equal to 12. Now I want to solve for k. 12 squared is 144. Multiply both sides by 144. And I believe we get 432. Yeah, 432. Now we plug that back into the formula from step 2, which is right here. We now know what k is. So we got y is equal to 432 over x squared. Step 4, find what they really want. It says, find y if x equals 15. Okay, so we want to find y when x is equal to 15. So we got 15 squared. So we got y is equal to 432 over, I think that's 225. Let me check. Yeah, 225. Trying to think if this simplifies any. I'm going to cheat and use a calculator. So I got 432 divided by 225, enter, and then I'll do math, enter. And I guess I did simplify. So it gives me 48 over 25. Now if you're wanting in decimal form, it'd be 1.92. Let's see what in the world this problem's asking for. I guess I should round your answer off to the nearest hundredth. Okay. Hundredth would be the second decimal place here, so they're looking for the decimal version like that. Okay, number 9. It says, give the restrictions on x to the following rational expression. If there are no values of x for which expression is undefined, then write no restrictions. So we got x squared plus x plus 8 over x squared minus 2x minus 8. Now remember, to say define the restrictions means find a domain, so we'll go through our 2 steps. First step is to set the denominator equal to 0 and solve it. So we got x squared minus 2x minus 8 equal to 0. Now this is a quadratic, so we want to use the zero factor property. So we want to factor it. This is PST because we have x squared x, no number in front of our x squared. Remember with PST we take the number at the end, ignoring signs, and create our 3 columns. So we got 1 times 8, 2 times 4. Add them. 1 plus 8 is 9, 2 plus 4 is 6. Subtract them. 8 minus 1 is 7, 4 minus 2 is 2. The number we're looking for is the number in the middle term, which is 2, which is right here, which means we'll use 2 and 4. Now our larger number, which is the 4, will always be the same sign as the middle term, which in this problem is a negative. The number of circles in the difference column, D for different signs, so if this one's negative, this one has to be positive. Zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x plus 2 equal to 0 and x minus 4 equal to 0, which gives us x equals negative 2 and x is equal to positive 4. Now remember, these are the values we cannot have, so we'll put a slash through the equals, and x cannot equal negative 2 and x cannot equal to 4. And those are our restrictions, or our domain. Let's start a new page. Okay, let's look at problem number 10. Craig and Pam working together can mow the lawn in 9 hours. Working alone, Pam takes 3 times as long as Craig. How long does it take Craig to mow the lawn alone? So let's look at Craig first. Craig, this is a shared work problem, so Craig would be 1 over x. And it says, working alone, Pam takes 3 times as long as Craig. So Pam would be 1 over 3x. And together, they tell us they can mow the lawn in 9 hours. So that'd be 1 over 9. Now this is a rational equation. So first step is we want to get rid of parentheses, don't have any. Second step is get rid of fractions. Multiply everything by the LCM of all your denominators. If I look at my numbers first, I got 3 and 9, so my LCM would be 9. If I look at my x's, I'm looking for the greatest number of x's in a single denominator. There's 1 here, there's 1 here, there's none here. So greatest number of x's in a single denominator is 1. So our LCM is 9x. And I'll multiply that times 1 over x. I'll multiply that times 1 over 3x. And I'll multiply that times 1 over 9. Well, these x's are going to cancel. So those are gone. This x cancels that x. 3 and 9 are both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. And these 9s will cancel. So I'm left with 9 times 1, 9, plus 3 times 1, 3. And over here, x times 1, x. So we got x is equal to 12. That's Craig. How long does it take Craig to mow the lawn alone? Okay, that's all they're asking for, I guess. So that'd be your answer. Number 11. One number is 2/3 of another number. Sum of the two numbers is 35. Find the two numbers. Okay, so we got first number, and we got our second number. First number, we want to know what it is, so it's x. This says one number is 2/3 of another number. 2/3 of. Of means multiplication. So that means 2/3 x. And then it says the sum of these two numbers is 35. So we want to add them together. So we got x plus 2/3 x equals 35. Well, let's go through and solve this. First step is to get rid of parentheses. Don't have any. Second step is to get rid of fractions. I only have one denominator, so that is my LCM. So I'll multiply everything times 3. So 3 times x, 3 times 2/3 x, and 3 times 35. So we got 3x. Here these 3's are going to cancel. And we got 2x left. And over here, 3 times 35 gives me 105. 3x plus 2x is 5x. Always combine together like terms. Divide both sides by the number in front of your x, which is 5. And 105 divided by 5 gives us 21. So that'd be our first number. Find the two numbers. So this one's 21. Together they add up to 35. Which means if this is 21, the other one has to be 14, I guess. You could also take 2/3 times 21 to get that result. But 21 and 14 are our two numbers. Okay, number 12. Yeah, probably got room here. We got 3 over x plus 5 squared. Times x squared minus 25 over 6. And the instructions say perform the indicated operation of multiplication, division, and rational expressions and simplify. This is multiplication. Our first step is to factor everything. Can't do anything with the 3. X plus 5 squared. That means x plus 5 times x plus 5. X squared minus 25 is a difference of two squares. Two terms, the minus between it. And let me do it right here. The factoring. So we got x squared minus 25. Remember, we try to write it as something squared minus something else squared. We ask ourselves what times itself gives us each individual piece. X times x gives you x squared. 5 times 5 gives you 5. I'll label what's inside my first set of parentheses as F for first, and what's in my last set of parentheses is L for last. And we got F plus L, F minus L. Now everywhere I have an F, I'll plug in X, and everywhere I have an L, I'll plug in 5. So I got X plus 5 and X minus 5. go. Step 2, cancel. Only guideline is one's on top, one's on the bottom, they're the same. If we're talking about factors, talking about numbers treated differently. Well, here's an x plus 5 and here's x plus 5. Now the numbers, one's on top, one's on the bottom, and you ask yourself what's the largest number divides into both of those. Well, 3 and 6 are both divided by 3. 3 divided by 3 is 1, 6 divided by 3 is 2. So we're left with, up on top, I guess just x minus 5. And down below we're left with 2 times x plus 5. And we don't need to do any other steps because that's as much canceling and reducing as we can do. Okay. Those are all together, just so we can clearly see it. Let's look at 13. A safe load L of a wooden beam supported at both ends varies jointly as a width and blah 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 and inversely. Varies jointly and inversely. Well, the fact that it says varies means it's a variation problem. Step 1. Determine type. It's a combo because it has not only words joint, here's joint, but also inverse. So there is no specific form for the combo. You just write it down as you read it. Keep in mind where your varies is where your equals goes. So safe load L of a wooden beam supported both ends varies jointly. There's my varies, which is the equals. So L equals. Varies jointly as a width W. So we got KW. The square of the depth D, so D squared. And inversely, now the inverse part, inversely is the length L. The inverse part always goes down your denominator. So this will be L down here, lowercase l. Step 3, look for your one example. A wooden beam 5 inches wide, so W is 5. Um, 8 inches deep, so depth is 8, so that's D, I guess. So that's 8 squared. Over, and 19 feet long, so 19 is my L. Holds up to 3,551, so that's my load, 3,551. Now we want to solve for K. So I multiply both sides by 19, so I got 3,551 times 19 equals 8 squared, 64, times 5 times K. So 64 times 5 times K. 3,551 times 19. You got 67,469. And 64 times 5 gives us 320K. Okay, then divide both sides by 320. That didn't come out very nice. Let me leave it in fraction form. Eventually get back there. There we go. So 67,469 over 320 equals K. I'm not going to worry about trying to simplify that, but we now plug that into our formula from step 2, which was this right here. So we got L is equal to 67,469 over 320 WD squared all over L, little l. Step 4, find what they really want. They say, what do they say? what load, so what would L be? What load would a beam 6 inches wide, so telling us W is 6. So I got 67,469 over 320 times, what did I say? Okay, 6 wide, so W is 6, times 10 inches deep, so this would be 10 squared, divided by the length, which would be 18 feet long. Okay, now I should already have that other one in my calculator. This right here is this first fraction, so times 6 and times 100. So times 6 times 10 squared divided by 18. And we got 7,028. And I think it round off your answer to the nearest pound. So that'd be your answer. Okay, let's look at 14. Z is jointly proportional. Now it doesn't say variation, but proportional is another word for variation. And it says joint. So, it's a variation problem. Our first step, determine type, and it tells us joint. Now again, joint is typically of this form, y is equal to kxz. I'll pick variables that make sense. It says z is, so we got z is directly proportional to x squared and y to the third. So x squared and y to the third. Step 3, look for your one example. If z is 431, when x is 2 and y is 3, so x is 2 and y is 3. Well, we're going to use that to find k. So we got k times 2 squared is 4 times 3 to the third, which is not 9, 27. So we got 431 is equal to 108, I think. Okay. Let's see, 108. Divide both sides by 108, and that'll be our k. And we want to plug that into the formula from step 2, which is this right here. So z is going to equal to 431 over 108, x squared, y to the third. Step 4, find what they really want. Find z when x is 3 and y is 7. So x is 3 and y is 7. X is 3 and y is 7. Round off your answer to the nearest hundredth. So let's plug that in our calculator. 431 divided by 108 times 3 squared, 9, times 7 to the third, and round to hundredths, which means 2 decimal places. So we got z is equal to 12,319.42. And that's our answer. And let me save that. Close that and start a new one. Okay, let's take a look at this. 15. An airplane can travel 355 miles in still air. If it travels 2,562 miles with the wind in the same length of time. It travels 2,408 miles against the wind. What is the speed of the wind? The same time. This is all based upon this formula. D is equal to RT. And if I solve this for time, I divide both sides by R. We get RT is equal to D over R. So we got same length of time with the wind against the wind. So we got with and against. And we said times are the same, so we're setting D over R equal to on both of these. Okay, so with the wind. With the wind. So 2562 over, and then against the wind. Travels to against the wind, 2408. Well, we got 2562 with the wind, which means I know what this is. It's 355 miles in still air. And with the wind means the wind's pushing against your back, which means you'll have 355 plus x because you're going faster. Now against the wind's blowing against you, which means you're going to have 355 minus x. Now this is a proportion, so we want to cross multiply. So multiply those two together and multiply these two together. So we got 2,562 times 355 minus x equals 2408 times 355 plus x. Okay, this is a distributive property. So we're taking this 2562 and multiply it times 355 and times negative x, and taking this 2408 and multiplying it through. So 2562 times 355 gives us 909,510 minus 2,562x. Now we're on this side. We're going to multiply these together. So we've got 2408 times 355. And we get 854, 840. And 2408 times x gives us 2408x. Okay. Now we want to get everything with an x on one side, numbers on the other, so I'll take that number over and take this term over to the right side. So we'll get 909,510 minus 854, 840 equals 2408x plus 2562x. Okay, so we got 909,510 minus 854, 840 gives us 54,670. And adding those two together, we got combined like terms, so 2408 plus 2562. That'll give us 4970x. Divide both sides by 4970. So we've got 54,670 divided by 4,970. So we've got 54,670 divided by 4970. And we get 11. Well, let's see what in the world it's asking for. What is against the wind? What's the speed of the wind? Okay, yeah, that'd be right then. That's just what they're asking for. Because this is your speed, 355, and yeah, then that'd be the wind. Okay, number 16. Let me just look, see how many of the problems there are. Ugh, never ending. Number 16. We got 3y squared over 4 times x squared minus 64 divided by 2y over 8x minus x squared. Well, first off, we never actually do division, so we immediately rewrite as multiplication. So that changes to times, and then we flip our second fraction, take the reciprocal of it. So we got 8x minus x squared over 2y. Now this is multiplying a rational expression, and our first step is to factor everything. Now this is dots, two terms, the minusing it. This one is wrong order. It's not in a standard form. So we're going to have 3y squared over 4 times x squared minus 64. Actually, let me go ahead and factor that part. Okay, x squared minus 64. We said difference two squares, so we try to write it as something squared minus something else squared. Well, x times x gives you x squared, and 8 times 8 gives you 8. And remember, our formula is what's inside the first set of parentheses f for first, what's in the last set of parentheses is L for last. And this is f plus L times f minus L. So everywhere I have an f, I'll plug in x, and everywhere I have an L, I'll plug in 8. So we've got x plus 8, x minus 8. Okay, so x plus 8, x minus 8. Times negative x squared plus 8x. Remember, when you rearrange terms, whatever sign's in front of them have to go with them. So that negative is in front of x squared remained out in front of the x squared. Now, I can factor the GCF. So we got 3y squared over 4 times x plus 8 times x minus 8 times, and the GCF is negative x. First term is negative, so we always bring out a negative, and they both have an x. And that gives us x minus 8. Well, now we're ready to do some canceling. And our guideline is one's on top, one's on the bottom, they're the same when you're talking about factors. So we got x minus 8 here, and we got x minus 8 here. So we have 3y squared over 4 times x plus 8 times negative x over 2y. Okay, when we're dealing with numbers, basically if you can divide a number on top and a number on the bottom by the same number, do so. 3 and 4, 3 and 2 can't do anything with. But the y's. Notice we have y to a power over y to a power, so we can do some simplifying there. So this becomes 3y over 4 times x plus 8 times negative x over 2. Remember, if you have y to a power over y to a power, you subtract smaller exponent from larger one. 2 minus 1 would give us 1, so we're going to have y the first where our larger exponent was. Then this y disappears. Doesn't look like there's anything else I can simplify, so I'll multiply. Multiply top parts together and bottom parts together. 3y times negative x gives us negative 3xy. Down here, 2 times 4 gives us 8 times x plus 8. Typically, you don't actually multiply that through what you see there. You just leave it in that form. Okay. Number 17. Notice it says the distance of a tree falling of a free-falling object. The distance that a free-falling object falls is directly proportional. Proportional is another name for varies. So this is a variation problem. It says direct. So it's a direct variation. So step 1, determine the type. It tells us it's direct. And that's typically of the form y is equal to kx. So step 2, pick variables that make sense. Distance that a free-falling object falls is directly. Here's the is our equals. So d for distance is directly proportional to the square of the time it falls. So t squared Step 3, look for your one example. If an object fell 81 feet, so square of the time it falls is directly the distance that it falls. So 81 is the distance it falls, so 81 is our d. If an object fell in 4 seconds, so I'll put 4 in for my time, keeping in mind this is in seconds. So we got 81 is equal to 4 squared is 16. Divide both sides by 16. We got 81 over 16 is k. And now we want to plug that into our formula from step 2. So we now know what k is. So we got d is equal to 81 over 16 t squared. Step 4. Find what they really want. How far will it have fallen by the end of the 5 seconds? So how far, it wants to know the distance. D is equal to 81 over 16, and I think it said 5 seconds, so put 5 in for the t. Leave the variation constant in fraction form around at least 2 decimal places. Round your final answer to the nearest foot. Okay. So I got 81 over 16. Times 5 squared. And round it to the nearest, so it'll be 127. So D is 127 feet. Okay, let's look at number 18. That looks like a long one. Let me save off my page. I don't know if I got enough room there for it. There we go. And so number 18. We got y squared minus 8y plus 15 over y plus 7 divided by y squared plus 3y minus 40 over y plus 7. We never actually work with division, remember? So we're going to have y squared minus 8y plus 15 over y plus 7. And how we get rid of division is we immediately rewrite as multiplication by flipping the second fraction, taking the reciprocal of it. So this will be y plus 7 over y squared plus 3y minus 40. And now we're ready to multiply. Step 1, factor everything. Now this one's PSD, because we have y squared y, no number forever y squared. This one's PSD, because we have y squared y, no number forever y squared. Now these can't factor. Okay, with PSD, remember you take your number at the end, ignoring signs. So in this one I'll take 15 and come up with our 3 columns. P, write down all products, give us 15. We got 1 times 15, 3 times 5. The S column, want to add these together. 1 plus 15 is 16, 3 plus 5 is 8. Difference column, subtract smaller from larger. 15 minus 1 is 14, 5 minus 3 is 2. Number we're looking for is always a number in a middle term, which is 8. So we're going to use 3 and 5. Now our larger number that we're using 3 and 5, so larger one's a 5, will always be same sign as the middle term, which in this problem is a negative. Number I circled in the S column, S for same sign, so if this one's negative, this one has to be negative. Now let's look at this denominator. The PSD, take number at the end, which is 40, and create our 3 columns. We got 1 times 40, 2 times 20, 4 times 10, 5 times 8. Add them. 41, 22, 14, 13. Subtract them. 40 minus 1 is 39, 20 minus 2 is 18, 10 minus 4 is 6, 8 minus 5 is 3. Number we're looking for is a number in the middle term, which is 3, which is right here, which means we'll use 5 and 8. Now our larger number, we're using 5 and 8, so larger one's the 8. Large number is always same sign as the middle term, which in this problem is a positive. Now a number I circled in the difference column, D for different signs. So if the 8 is positive, the Y, or the 5 is negative. Step 2, cancel. Only guideline is one's on top, one's on the bottom, they're the same. So we got Y minus 5 here, Y minus 5 here. We got Y plus 7 here, Y plus 7 here. So we're left with Y minus 3 over Y plus 8. And that's our answer. Okay, number 19. Got 8 over X minus 1 plus 5x plus 18 over, let's try it again, 5x plus 8 over x squared plus 4x minus 5. Now this is adding or subtracting rational expressions. In this case, adding. First step is get rid of parentheses, don't have any. Second step is to get a common denominator. And the first thing we have to do is we have to factor all of our denominators. X minus 1 we can't do anything with, but this one's PSD. Reason why is because we have an x squared x, no number in front of our x squared. Again, with PSD, take the number at the end, ignoring signs. So we got 5. And come up with all products, give us 5. We got 1 times 5. Add them. 1 plus 5 is 6. Subtract them, smaller from larger. 5 minus 1 is 4. Number we're looking for is a number in a middle term, which is 4, which is right here, which means we use 1 and 5. So we got 8 over x minus 1 plus 5x plus 8 over x1, x5. Our larger number, we got 1 and 5, so our larger one's a 5. Our larger number will always be the same size as the middle term, which in this problem is a positive. Number we circled in the difference column, D for different signs. So if this one's positive, the other one has to be negative. Okay, now to get our common denominator, we'll start with our first factor. I'll start with x minus 1. I'm looking for the greatest number of x minus 1s in a single denominator. There's 1 here, there's 1 here, so the greatest number of x minus 1s in a single denominator is 1. Then I go to my next factor, the x plus 5, and I'm looking for the greatest number of x plus 5s in a single denominator. None here, 1 here, so greatest number of x plus 5s in a single denominator is 1. So that'd be our common denominator. Now this one already has it, so I don't have to change it at all. But my first fraction, I have to look at what is still there. We got x minus 1, x minus 1, so that's still there. The new item down below is the x plus 5. Now whatever new item we put down below, we have to put up on top. So I'm going to put an x plus 5 there. Well, 8 times x is 8x. 8 times 5 is 40 over our denominator. Plus 5x plus 8 over x minus 1, x plus 5. Now that they have the same denominator, I can add or subtract top parts. In this case, add. So we got 8x plus 40 plus 5x plus 8 over x minus 1, x plus 5. That was step 3, by the way. which gives us 8x plus 5x is 13x, 40 plus 8 is 48, over x minus 1, x plus 5. And that would be our answer. Okay, let me get a drink here. Then we'll look at the next problem. Okay, so guess we're ready for number 20. It says if y is directly proportional, well, again, it says proportional. That's another word for variation. So we got a variation problem. So step 1, determine type. It says direct. It says directly. Typically, direct is something of this form: y is equal to kx. So let's see what we got in this problem. If y is, okay, so we got y equals, the is where equals goes, directly proportional to x. That doesn't change any. That's the same setup here. Okay, step 3. Look for your one example. Directly proportional to x, and y is equal to negative 21 when x is 41. So they're telling us y is negative 21 and x is 41. That's our one example. We want to use that to find k. So divide both sides by 41. So we've got negative 21 over 41 is equal to k. And now we want to plug that into the formula from step 2. So we got y is equal to negative 21 over 41x. And step 4, find what they really want. Let's see, find y if x is 34. So we want to find y, and they're telling us that x is 34. Round off your answer to the nearest hundredth, so round to 2 decimal places. So I got negative 21 divided by 41 times, let's try it again, negative 21 divided by 31 times, where did that 31 come from? I was out shoveling snow earlier. I think it maybe destroyed some of my brain cells. It should be 41. Okay, let's try it again. Negative 21 divided by 41 times 34. Makes me wonder how many mistakes I've made in this review. Negative 17.41 to 2 decimal places. And let's see what problem's next. Let's save that. There we go. And let's start a new page. So we got 21. Says, in a zoo, the ratio of adults to children is 4 to 12. 4 adults and 12 children. It says if there are 80 people in the zoo, how many children there are. So what they're asking us here is they're putting it in terms of children over the number of people. Well, you have to remember that 80 people in a zoo, how many children are there? To say something's a person, or say somebody's a person, means that includes children. Children are people. So this right here, where it's 4 and 12, we don't put 4 over 12 for adults to children, or actually we do 12 over 4. Instead, we need it as 12 for the children over the total number of people. In this case, it would be 16. So again, 12 here refers to my children, and then 16 refers to my people. 16 I got by adding 4 plus 12. Okay, now tell us that there's 80 people in a zoo. So put 80 people. And they're wondering how many children. So that's going to be our x, the children. We can drop the units of measure and cross multiply now. What I mean by cross multiply is we multiply these two together and multiply these two together. So we got 16x equals 12 times 80. So we got 16 equals 96 with a 0. Let's see, 0, 6, 1. Yeah. Divide both sides by 16. And I shouldn't have to do this, but 60, I think. 0, 6, 3, yeah, 60. Now that's the number of children. Let's see what they're asking for. How many children are there? So it'll be 60 children. That one's kind of tricky. If I didn't read it close, I might have set this up differently. I might have just went ahead and put 12 over 4 and got some bizarre results. So you have to really look to see the kind of relationship they're talking about, where children to people. Okay, number 22. Got x over x minus 1 minus 3x over x squared plus x minus 2 equals 4 over x plus 2. This is a rational equation, and they say state any restrictions on the variables. So let's do that first. Actually, let's factor first. Actually, let's solve the equation, then we'll do the restrictions. So I'll kind of do it backwards. Okay, so first step in solving a rational equation, get rid of parentheses. Don't have any. Second step is to get rid of fractions. Multiply everything by the LCM of all your denominators. Now we have to factor all of our denominators to help figure that out. So this one would be the PSD method, because we have x squared x, no number in front of our x squared. We take our number at the end, which is 2, ignoring signs, and come up with our PSD table. We got 1 times 2, add those, 1 plus 2 is 3, subtract them, 2 minus 1 is 1. Number we're looking for is the number in the middle term, which is 1, which is right here, so we're going to use 1 and 2. Okay, so we got x over x minus 1 minus 3x over x1, x2 equals 4 over x plus 2. Now our larger number in the P column that we're using 1 and 2, so larger one's a 2, will always be the same sign as the middle term, which in this problem is a positive. Number of circles in the difference column, D for different signs, so if this is positive, the other one has to be negative. Now, while we're here, let's go ahead and look at part A. It's best to have these all factored if you're trying to answer the domain, what they cannot be, the restrictions. Since this is x minus 1 and this is x minus 1, I only need to set one of them equal to 0. So I get x minus 1 equal to 0. Solve for x, we get x equals 1. And this, since these are both x plus 2, I just need to set one of them equal to 0. And that gives us x equals negative 2. Now we put a slash through these. And these are the values that x cannot be. Because if I put a 1 in here, 1 minus 1 will give us a 0. If I put negative 2 in here, negative 2 plus 2 will give us 0. So these are restrictions. X cannot be 1, x cannot be negative 2. Okay, let's continue working this problem. Got to figure out what our LCM is. So I'll look at my first factor, the x minus 1. Now I'm looking for the greatest number of x minus 1s in a single denominator. There's 1 here, none here. So the greatest number of x minus 1s in a single denominator is 1. Then I go to my next factor, the x plus 2. And I'm looking for the greatest number of x plus 2's in a single denominator. None here, 1 here, 1 here, so it'd be 1. So that's going to be our LCM. And we'll multiply it times our first fraction, minus, and we'll multiply it times our second fraction here. And I'll put it after. Multiplication is commutative, so it doesn't matter if you put it before or after. And then I'll multiply it times the fraction on the right side. And this x minus 1 cancels that x minus 1. This x minus 1 cancels that x minus 1. This x plus 2 cancels that x plus 2. And over here, these x plus 2's cancel. So we're left with x times x plus 2 minus 3x equals 4 times x minus 1. Distributive property, x times x is x squared, x times 2 is 2x, minus 3x equals 4 times x is 4x, 4 times negative 1 is negative 4. Always combine together like terms. 2x minus 3x is negative 1x or negative x. Okay, now we want to solve for x. This is a quadratic, which means we want to get everything over one side, 0 on the other, because we're going to use zero factor property. So take 4x over, take negative 4 over. So we get x squared minus x minus 4x plus 4 equals 0. X squared minus 5x plus 4 equals 0. Okay, zero factor property says I have to factor this now. This is PSD because we've got x squared x, no number in front of our x squared. So take the number at the end, 4, come up with our 3 columns. We got 1 times 4, 2 times 2, add them. 1 plus 4 is 5, 2 plus 2 is 4. Subtract them, 4 minus 1 is 3, 2 minus 2 is 0. Number we're looking for is a number in a middle term, which is 5, which is right here, which means we'll use 1 and 4. And what did I just do? Okay. Getting sleepy. So we have 1 and 4. Larger number, we're using 1 and 4, so the larger one is a 4. Will always be the same sign as the middle term, which is negative. Number I circled in the S column. S for same sign. So if this one's negative, this one has to be negative. Zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 1 equal to 0, and I'll set x minus 4 equal to 0. Which gives us x equals 1, and x is equal to 4. Maybe. But remember our restrictions. We said that x cannot equal to 1. So that one's going to disappear, and our only answer is x equals 4. Okay, let's take a look at the next one. Take a look at 23. We got 5 over 8x minus 1/6 equals 3 over 2x. This is a rational equation again. First step, get rid of parentheses, don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. Well, if I take a look at 8, 6, and 2, that would be, what would that be? 24. Now for the x's, I'm looking for the greatest number of x's in a single denominator. There's 1 here, none here, 1 here. So the greatest number of x's in a single denominator is 1. So our LCM is 24x. So I'll multiply that times 5 over 8x minus 24x times 1 over 6 equals 24x times 3 over 2x. Now these x's cancel here. 8 and 24 are both divisible by 8. 8 divided by 8 is 1. 24 divided by 8 is 3. Here, 6 and 24 are both divisible by 6. 6 divided by 6 is 1. 24 divided by 6 is 4. Over here, these x's are going to cancel. 2 and 24 are both divisible by 2. 2 divided by 2 is 1. 24 divided by 2 is 12. So we're left with 3 times 5, which is 15, minus 4 times x, which is 4x, equals 12 times 3, which is 36. Get everything with an x on one side, numbers on the other. So take negative 4x over, take 36 over here. So we've got 15 minus 36 equals 4x. What was that, negative 21? Yeah, negative 21 equals 4x. Then divide both sides by 4. And we got x is equal negative 21 over 4. Now restrictions on x are, in this problem, we cannot have x equal to 0. Because if I put 0 in here for x, 8 times 0 is 0, we'd have 0 for the denominator. So this is our answer. 24. We've got negative 4 over 4 equals negative 8 over negative 8x. Before I do anything in this problem, I notice that fractions can simplify. 4 and 4 are both divisible by 4, so I got negative 1 over 1. And here, negative divided by negative becomes positive, and 8 and 8 are both divisible by 1, or both divisible by 8. 8 divided by 8 is 1, and 8 divided by 8 down here is 1 with an x, or just x. Now the restriction on this is, I think they're asking for restriction, is of course we cannot have 0 as a remainder. So x cannot equal to 0. Now this kind of bizarre looking, but this is still a proportion. Single fraction equals single fraction. So we can cross multiply. So we're going to have negative 1 times x, and we'll have 1 times 1. So that gives us negative x is equal to 1. Divide both sides by negative 1, and you end up with x equals negative 1. And that's our answer. Let me save this page. And start a new page, I guess. Or wait, yeah, start a new page. And let's take a look at number 25. We got negative 4x minus 3 over x plus 5 minus 3x plus 4 over x plus 5. Now here we're subtracting, and it says from indicated subtraction. Okay, so we're subtracting these two. Now they already have the same denominator, so that works out well. And with subtraction, remember if you have a minus out in front of your fraction, that flips the sign of everything up on top. So it's going to flip the sign of 3x and a 4. So let's merge these together. So I got negative 4x minus 3 minus 3x minus 4 over x plus 5. Combine together like terms. Negative 4x and negative 3x is negative 7x. Negative 3 and negative 4 is negative 7 over x plus 5. Now always you try to simplify. And I notice on top I got a GCF, so I can factor that out. So I factor out a negative 7, and that gives me x plus 1. Nothing I can do with the bottom. After I get done factoring, I notice that I can't simplify it any further. So that would be our answer. 26. Form the indicated operation. So we've got 15s squared over 36t. These are like my worst variables ever. 6s squared over 3t. Instructions say to perform the indicated multiplication or division and the rational expressions simplify. Okay, to begin with, before we multiply them together, let's do some simplifying. Here's 13, or here's 5 and 3, both divisible by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. So we have 5s squared over 36t times 6s squared over t. Now here we got a 6 and 36. Both divided by 6. 6 divided by 6 is 1. 36 divided by 6 is 6. So we're going to have 5s squared over 6t times s squared over t. Nothing else I can simplify, so let me multiply across. S squared times s squared gives us s to the fourth. Down here, t times t gives us t squared. And that would be our answer. Okay, 27. Says the volume of a gas in a container varies inversely as the pressure. Varies. It's a variation problem. Step 1. Determine the type. And it says varies inversely, so it's an inverse problem. And our inverse is typically of this form: y is equal to k over x. We just have to see what this particular problem is like. So let's read it again. Keep in mind where the varies is your equals. Okay, volume of a gas container. V for volume. Varies, so those are my equals. Inversely as the pressure on the gas. So K over P. The inverse part always goes down your denominator. Step 3, look for your one example. If a gas had a volume of 290, so volume of 290, under a pressure of 15, so P would be 15. And we'll use that to solve for K. So I multiply both sides by 15. 290 times 15. And that gives us 4350. Now we want to plug that into our formula. So volume is going to equal to 4350 over P. Step 4. Find what they really want. If a gas, what will be the volume if the pressure is increased to 17 pounds? Increased to. Not increased by, but increased to. Very important wording. So they're telling us that P is now 17. Make sure everything matches up. Cubic inches. Wait a minute. Pounds per square inch, pounds per square inch. So everything matches there, so it's simple as plugging in a number. And it says round off your answer to the nearest cubic inch. What in the world does that mean? Okay, no decimal places. I was thinking cubic had to do with decimals. Okay, so 4350 divided by 17. And nearest one would be 256. There we go. Let's look at number 28. From the indicated operation, okay, and reduce your answers. So we got 3x over x minus 9 plus 4x over 9 minus x. First off, I notice they don't have the same denominator, so I need to factor all the denominators and get a common denominator. Well, this first one's okay, but second one's in the wrong order. It's not in standard form. So we're going to have 3x over x minus 9 plus 4x over negative x plus 9. Now once I put it in standard form, then I notice that my first term is negative. And GCF says you always pull out a negative if your first term is negative. So you got 3x over x minus 9 plus 4x over negative 1 times x minus 9. Now in this particular case, if you got a negative 1 like that, you can take that and put it out in front. So we got minus 4x over x minus 9. Well, now that they have the same denominators, I can add or subtract top parts. So I got 3x minus 4x over x minus 9, which is negative 1x or negative x over x minus 9. And that's our answer. Okay, 29. If Colleen were to paint her living room alone, it would take 4 hours. Her sister Evelyn could do the job in 7 hours. How long would it take them working together? Okay, so this is a shared work problem. So Colleen, it takes 4 hours. So Colleen would be 1 over 4. Plus, Evelyn could do the job in 7 hours. So it would be 1 over 7. And it's wondering, how long would it take them working together? So this side is always your together, so that's 1 over x. This is a rational equation, so I multiply everything by the LCM of all my denominators. 4 and 7, the LCM would be 28, and then we'd have an x. So we'd take 28x times 1/4 plus 28x times 1/7 equals 28x times 1 over x. Well, 28 divided by 4 is 7, so we got 7x plus 28 divided by 7 is 4, so we got 4x equals, those x's cancel, and we got 28. So that gives us 11x equals 28. And then divide both sides by 11, and we get 28 over 11. If needed, submit your answer as a fraction reduced to lowest terms. So this would be our answer. Okay, number 30. Looks like we got a proportion. So we got x plus 5 over x minus 1 equals 6 over 3. State any restrictions? Well, the only restriction I see is if I set this denominator equal to 0 and solve it, I get x equals 1. So if I were to put 1 in for the x, 1 minus 1 is 0, we can't have 0. So x cannot equal to 0 is our restriction. Now, this is a proportion. Single fraction equal to single fraction, so I cross multiply. I could simplify that 6 over 3 first if I wanted to, but okay, so I'll take 3 times x plus 5 equals 6 times x minus 1, which gives us 3x plus 15 equals 6x minus 6. Want to get everything with an x on one side, numbers on the other, so take 6x over there, take 15 over here. So we got 3x minus 6x equals negative 6 minus 15. So we got negative 9. Let's try it again. I'm getting tired, I guess. 3x minus 6x is negative 3x, not negative 9x. Negative 6, negative 5 is negative 21. Divide both sides by negative 3. And we get x is equal to 7 as our answer. Okay, now I'm going to do one more that's not on the review that you need to know for the test. Just to refresh your memory on long division. Start a new page here. There we go. Okay, so we got, let's see, x plus 1, and then x to the third minus 7x plus 2. First off, what's out in front, what's underneath must be in standard form and not be missing any powers. The x plus 1's okay, but this, we got an x to the third, but we're missing the x squared. So I'm going to put a 0 placeholder. So I got 0x squared minus 7x plus 2. Again, this must be in standard form, this must be in standard form. Standard form is where the terms range from largest power down to smallest. And you can't have any missing powers. So if you're missing any, you have to put a 0 placeholder. Okay, we're going to start with our first term in each to decide what to put up on top. We ask ourselves what times x gives us x to the third, and that's x squared. Now whatever you put up on top, you're going to multiply by what's out in front. So I got x squared times x plus 1, and that gives us x to the third plus x squared. Now we're going to subtract that line, which means flip signs. So this becomes negative, and this becomes negative. X to the third minus x third drops away. 0x squared minus x squared gives us a negative x squared. And I'll go ahead and bring everything else down. Now again, we'll look at the first term of each side, what to put up on top. You ask yourself what times x gives you negative x squared, and that's negative x. And again, whatever you put up on top, you multiply by what's out in front. So we're going to negative x times x plus 1, which gives us negative x squared minus x. Now we're going to subtract that line, which means flip signs. So this becomes a positive, this becomes a positive. Negative x squared plus x squared drops away. Negative 7x plus x gives us negative 6x. Then I'll bring down 2. And again, we're going to look at the first term of each side, what to put up on top. So you ask yourself, what times x gives you negative 6x? And that'd be negative 6. And whatever we put up on top, we're going to multiply by what's out in front. So we'll take negative 6 times x plus 1, which gives us negative 6x minus 6. We're going to subtract that line, which means flip signs. So this becomes positive, this becomes positive. Negative 6x plus 6x drops away. 2 plus 6 is 8. Now the degree of this 8 is 0. Degree is the largest power of x. The degree of the x plus 1 is 1. When this degree is less than what you're dividing by, then this is always your remainder no matter what it looks like. So we're going to put the 8 over what we're dividing by. And that's our answer.